Good afternoon, everybody. So follow Youngson's impressive talk. I'm going to talk about how do we build customized solutions for Alibaba Cloud using open sources. First question we would like to ask in our companies, why do we need open sources? There are three major reasons that we considered why we do open source. First of all, Alibaba Cloud is one of the biggest clouds in the world. We need to cover end-to-end, from edge devices to the clouds. That diversified applications, we need an open sources to collaborate from edge to the cloud. The second thing is we need to have customized solutions. We need to have our ownership of the architectures, of the computers, and also the software. So it's a vertical market that we are talking about. We're not just working on the chips, CPUs, but we also have OSs and also the applications in our business. For example, Taobao and financial systems. The third, as the previous speaker mentioned, collaborative. We would like to contribute to the society, to the world that we developed to share with our vendors and also our customers. Looking at the specific cloud applications, and the left-hand side, you can see this is the applications we have from the edge side. We have smart panels, smart voice, graphics, and up to the computer visions. The CPUs we're building ranging from frequency like 200 megahertz up to 1 gigahertz or even 2 gigahertz. Besides this, we also need to have our operating systems. So we also work with different vendors on the FreeRTOS, Linux, and Android as well. We believe end-to-end hardware and software co-design is the future. That is the things we would need to work on. On the right-hand side is the edge to the cloud. So a couple of months ago, we announced Alibaba Cloud. The operating system for that cloud will be working with multiple CPU architectures, especially including the RISC-V architecture. We were very excited and proud to announce the Open Xuantie, which is RISC-V family processors, a couple of months ago. We open sourced all these 4 processors, ranging from the very low power MCU applications to the high frequency, high performance C910 series, which was released about 2 years ago, but currently made totally open free. And all these processors can work with the operating systems we listed here: RTOS, FreeRTOS, Linux, and Android. At the right-hand side, you can see the standard architecture starts with the bottom. We have a RISC-V ISA. Then above that, we have our SoC platforms, which can help our customers to build RISC-V applications devices more efficiently and faster. And above that, operation system, and finally the application and algorithms for different areas. If you work in the CPU world, you must know that design CPU is not just hardware side. So software is very important as well. This picture shows the blue side is the lots of tools, debug capabilities, like compilers, all these. It's a software stack which help you to design CPUs. We all also make them open source. You can download from GitHub. At the right-hand side, based on the OS, we have different application APIs, video SDK, all these things which you can use to build your applications in your field. In the next 3 slides, I will cover the work we've done in the software side. How do we create our own operating systems and also other operating systems work with RISC-V. This picture shows the YOC operating system for IoT. YOC stands for Yun on Chip. Yun in Mandarin is just cloud. So we were trying to bring the capabilities of the cloud computing to the edge devices. On the right-hand side, you can see the orange areas that we developed and the gray areas we developed with our third parties to build from very bottom. RVM is the RISC-V interface for MCUs. Currently, we included 150 components and 30 more companies are using this. The left-hand side is the development board we use to demonstrate how that works. That board includes the embedded 906 Xuantie CPUs, which is also a RISC-V machine. The next one is Android. Android is everywhere, especially in the mobile computing. Early this year, we successfully started work and import the Android into the RISC-V. The left-hand side is the board that we used, and that chip includes the C910. C means compute, so it's high performance computing RISC-V machine. On the right-hand side, mostly is the Android components, and also we work with RISC-V International and also Google to move these things much faster in this direction. Till today, we contribute more than 100 GitHub libraries and also 2,000 plus files and more than 100K code lines. Last but not least, Linux. Linux is widely used in enterprise. So the left-hand side is the development board. We work with our customers. This board is the 1 gigahertz frequency volume production application processors in the market. And we also work with our customers and also RISC-V International to distribute this board to our community around the world, including universities, research institutions as well. We found the software work, Android work we did with this machine can smoothly make the transition between the Linux and RTOS as well. In summary, we believe the future is the open source world. We build customized solutions from open sources. In the pictures, in the middle, you see the processor series. From the E series is more embedded side, and for the C series, more computing high performance. And based on the requirements from industry controls, we also have developed the R series as well. So if you look at the pictures for the R series, it's more industry control, auto electronics. For the E series, it's MCUs, etc. And for the C series, we have smart voice and edge computing, edge servers. The other thing I would like to mention is that working with RISC-V International, we also start working on the servers using RISC-V. We believe by working together, we can build better CPUs. By working together, we can build more cost-effective devices for the IoT market and also for the server, for the mobiles in the future. By working together, we can build a better world, bright future for the industry. Thank you very much.